Hello everyone, good afternoon. Dear authors and invited guests, welcome to the technical session 1C. My name is Harsh. I'm the moderator of this technical session. And on behalf of Global Knowledge Research Foundation and Knowledge Chamber of Commerce and Industry, it is my great pleasure to welcome you all to the 7th International Conference on Information and Communication Technology for Sustainable Development through Zoom. I will I hope you will enjoy the knowledgeable and interactive sessions through the day. There's a special note for the presenters that you will be given 8 minutes for the presentation and 2 minutes for the question and answers. And 7 minutes, I will be raised a gentle reminder. And there's another request for the presenters that you will be please stay connected us till the closing remarks. Now, just before we get started, I would like to introduce you all to the chair for this session, Professor Deepak Mane. Uh, Dr. Deepak Mane is currently working as an associate professor in the Department of Computer Engineering, KSPM's Rajarshi Chahu College of Engineering. He has 16 plus years of teaching experience. His main research work focuses on machine learning, pattern classification, supervised clustering, and deep learning. His research profile is selected for Best Researcher Award in International Scientist Award 2021 on Engineering, Science, and Medicine, which held in Goa, India. Thank you, sir. Now, I'd like to start with the presenters. Our first presentation is B. Kartika, a review of deep learning healthcare problems and protection supports. She's going to presenting on this. Dear presenter, you may please start your presentation. She's not here. Maybe we can go over for our next presentation. Our next presenter is K. Vikas, and he is presenting on improving accuracy of ataxic gate monitoring using SVM and ANN. Dear presenter, you may please start your presentation.
I'll share my screen. So is my screen up?
Yes, it is visible, and make it please make it full.
Yeah. So let me start my presentation. Good afternoon, everyone. So we have connected a paper called in improving the accuracy of ataxic gate monitoring using SVM and ANN. And the authors are Sandhya and Vikas Surya and myself. We are going to present here. Our paper ID is 168. Now let's go to the details of the details of the paper. We have choose the base paper from the IEEE transaction of neural system from 2021, which relates to the deep learning for axiomatic data assessment and ataxic monitoring. Abstract. So gate monitoring belongs to the important disciplinary area that by the digital signal processing methods and machine learning too. So normally gate monitoring is nothing but that is one of the system where we will classify and we will check for the disorders in the movement of the gate people. Gate is a word where there is a distraction between the movement disorder. So this is analyzed based on different types using various machine learning algorithm like SVM, ANN to identify the fault through this methods. So introduction. So what was the main idea in this? To identify the uh, fault in the human walking disorder through various sensors like mentioned below, like MEMS, videos, and camera, by taking the reading from from the movement of the legs, and using various methods, we are going to process and do the calculations and obtain the result. So these are the various literature survey where we have taken the reference paper. So these are the algorithm they have used as k-nearest multi-layer perception, and everything has accuracy of 77 to 80%, and other related algorithm got around 40% and 88%. So in the existing system, they have tried using of Bayesian and SVM algorithm. This algorithm helps in the natural kinematics, which helps which will not have the which is for mainly for linear algorithm they are using for the evaluation of motion disorders. They have used this k-nearest and SVM algorithm. They have identified of around 81% of accuracy through these algorithms, and the visualization and the optimization for their base paper, it was little huge, and it was pros for their paper, and it's little bit high, and the data is also not yet pre-processed for this. So so that there will be a huge number of data getting processed, and then it comes to the end. So we have identified that that Bayesian and SVM algorithm, it is little difficult for the for processing of the data. So the accuracy also is becoming less due to this. So we have proposed the system with the artificial neural network algorithm for the improving the accuracy. This will reduce some invasive procedure. That invasive procedure is nothing but something related to doing surgery in the movement in the legs for the patient to diagnose what is the problem on their leg. This can be avoided if we do with the machine learning algorithm like ANN. So these precision, recall, efficiency, and execution can be calculated based on different algorithms. So our block diagram is that we provided data into that, and through pre-processing, we reduce the features into different category, and using SVM as a base paper, we are identifying, and in ANN, we classify the same algorithm, and finally, we identify the fault over it. So through the data set, we have processed the data consists of around 25,000 steps were acquired, and these steps were taken from the exercise that was done at the morning at the treadmill with a speed of different speeds from 0.6 to 1.7 at each speed. These data sets have been used, and with the help of this both the algorithm SVM and ANN, the classification has been done for the same. So we have done a pre-processing to this pre-processing has been not done in the SVM and k-nearest, so which leads to the large number of data in the data set, which takes little more time to execute. So let's see pre-process. So the data set is given as input, and through data set, the data is imported. This is the screenshot of the implementation. And after the feature reduction, we are doing this. This is using a eigenvector analysis. This eigenvector analysis is nothing but the two matrix. If we multiply, then the resultant will be also the same as PCA. Due to this, there will be many of the features getting reduced, and only the important features which are needed we can process through that. So SVM, as you know, that is only for linear data structure, linear files, where that only the single dimensional, it uses hyperplane where two axes will be there. So based on that, we solve the problems on the basis of the dimensions. So in this, in the SVM, they have done this changes, but we have obtained accuracy of around 0.79 as per the data we provided in the data set. And in ANN, as you know, it is for multi-layer, multiple non-linear data set where it can process more number of data than that of SVM algorithm. There is also some of the techniques where this neurons are interlinked with all the layer, and all the layer provides a specific number of nodes in which we can get the exact result from it. So at the end, we got around accuracy of 93% from the base of SVM and ANN. Accuracy is little more accurate than SVM. So this is the final chart we got obtained. So if we see over here, the SVM and ANN are classified, and the accuracy, everything is huge, and execution time has been reduced due to the pre-processing techniques. Yeah, this has been implemented through these different platforms. And finally, we have obtained the result, and we have found more accurate in ANN algorithm. And future, we can try with convolution neural network and recurrent neural network to implement this gate analysis. Thanks. Yeah, that's it.
Thank you.
Okay.
Yes.
Hello. Am I audible?
Yeah, you are.
Yes, sir, you are.
Okay. First of all, can you tell me support vector machine is a separate classifier and artificial neural network is a separate classifier. So when you combine both, so what is your contribution or what is your novelty when you are saying you got a 93% accuracy when you combine both?
Yeah.
So what is the exact the contribution or novelty when we combine both?
Yeah, so actually we have not combined both of the algorithm. To differentiate both algorithm using SVM and ANN, we have showed within the different category. We have not combined both the algorithm. SVM through non-linear, we are done for a separate separately, and ANN has been processed separately. We have not combined the both.
Do you have any other question?
Yeah. Okay. One more question from my side. In future work, you said we can use recurrent neural network and convolutional neural network, or recurrent and LSTM for to better improvement. So how we can improve? Why you include this technique in a future improvement?
Yeah, as we know, these algorithms are mainly for digital processing. We can go ahead with a convolution neural network, which will mainly used for the image processing techniques, and also there will be a many layers in that, and there will be a more accurate than the ANN algorithm, as that it has many features like many layers like convolution layer and like pooling layer and fully connected layer. These layers will be bringing out the features into a single fully connected layer, and we can get a result of more accurate.
Okay. Thank you.
Yeah, thanks.
Okay, so moving for our next participant. Our next participant is Shanmugh Sundaram, and is presenting on battery management systems in EV applications, review challenges and opportunities.
Hello, hello, sir. Can you hear me, sir? Hello.
Yes, we can.
Okay. Thanks. So my screen is visible, sir.
Yes, it is.
Okay, sir. So shall I start, sir?
Yes, please.
Okay, sir. So good afternoon to all of you. So the title of my paper is Battery Management System in Electric Vehicle Applications, Review Challenges and Opportunities. So myself, Shanmugh Sundaram, I am working at Sri Ramakrishna Engineering College, Coimbatore. My co-authors are Dr. Ravichandran and Mr. Ganesh Tamil Chelvi. Okay. So outline of my presentation. So it's going to cover introduction, need for battery management systems, features of BMS, SOC and SOH estimation techniques, battery modeling, cell balancing, finally conclusions and references. So the objective of this paper is to this paper presents the various challenges and opportunities in the development of battery management systems to meet the future needs and safety requirements. Actually, it is a review paper. So all of us know that rising oil prices and rapid depletion of oil resources and environmental concerns are driving demand and penetration of electric vehicles in the market. So one of the very important component of electric vehicle is battery management systems. Only through an effective battery management system, it is possible to ensure safety and reliability of electric vehicles, and also it is possible to reduce the battery maintenance cost, increase the safety and protection of the battery, and also it is possible to increase the life of the battery. So this is the block diagram of a battery management systems. So here DAQ stands for data acquisition system. So the parameters like voltage, current, temperature of the battery pack are measured using data acquisition system. And those parameters usually it will be given to your online parameter identification algorithm where the parameters will be identified. And using those parameters, yes, the state observer will use those parameters and it will estimate the value of the state of charge, state of health of the battery, and state of life. So, and these data are later used by the power management system to allocate power on the customer's requirements to achieve performance efficiency of the battery. So here the various functions of battery management systems are, so monitoring cell, like monitoring the parameters like voltage, current, temperature, then battery model parameter identification, then state of charge and state of health estimation. So these two parameters are very important parameters. Then cell balancing, this is another function, charge control, then temperature management, battery safety and protection. So these are the various functions of battery management systems. So the various research areas of BMS includes the development of precise battery model. This is one area where the researchers are working. So here we need a precise battery model to represent the battery's dynamic and static and dynamic behavior. The next thing is they're working on the development of online adaptive algorithm for the accurate estimation of SOC and SOH. Then so the research is also going on on creating a model of a cell. Then the research is also going on state estimation for implementing active cell balancing technique. then finally on improving the efficiency of the battery. So coming to the state of charge estimation techniques. So here the conventional techniques like Coulomb counting, it's an offline method. It's even though it is very easy to implement, but the limitation of this is the measurement of initial value of SOC. Initial value of SOC estimation or measurement is is not easy in this case, and also there will be accumulation of current sensor error over a period of time, and this also cannot be taken into account. And in this method usually the amount of charge flowing into the battery or out of the battery are counted in this method. The next method is OCV, open circuit voltage approach, but this approach is also offline method. It's found to be less accurate, but the accuracy of this method so can be increased by combining this first method, Coulomb counting method, and OCV method. So the accuracy of this method depends on the accuracy of mapping, the accuracy of SOC OCV mapping. Next one is electrochemical impedance spectrography method. It's offline method. So in this method the impedance is measured. So the drawback of this method is this process takes a longer time. So it is not preferred for particularly on offline estimation. Sorry, it is not preferred for online estimation, only it is preferred for offline estimation. Next is co-estimation approach, and the researchers are using nowadays, they are using this method. It's an online method. So here the accuracy of SOC estimation is increased, and also it is found that there is no need to compensate for the uncertainties. Then coming to the drawbacks of offline identification methods, and the first one is the battery model parameters are will remain constant, but practically so the battery parameters will vary, right? So but the results show that offline methods, so the parameters that is identified through offline methods differ from the batteries modeled on different environmental conditions and state of charges. So they're found to be quite different. So it is found that battery model parameters, they change. Even the SOC is changed from 0 to 100% at a fixed discharge and temperature. So what we have to understand is in the offline methods, the battery parameters are kept constant, and therefore so this fixed parameters model, if we are using, and definitely it is not possible to estimate accurate value of SOC and SOH. Then SOC co-estimation approach, right? So this is one of the approach, recently developed approach, and it is an online parameter algorithm that is used to identify the battery model parameters. So in this approach, OCV, SOC, OCV piecewise linear mapped curve is used, right, to obtain the model parameters. And also after obtaining the model parameters, and they are also updated online so that the parameters reflect the static and dynamic behavior of the battery. The SOC of the battery is estimated using advanced observers. So these observers basically they are based on state space model and the continuous updated battery model. So the updated battery model parameters are used, right, by the observer to estimate SOG. So the results of this method indicates that the accuracy of SOC estimation is increased, right, and the additional
Sorry to interrupt you,
compensations.
but we
Okay.
have last 1 minute.
Okay, fine, sir. So this is the block diagram, sir. of SOH estimate. Next, SOH estimation. Basically, SOH indicator is an indicator of how much charge is available in the battery for future use, and the battery charge holding capacity, which indicates the battery health. So most researchers considers only the capacity degradation and internal resistance increase to measure the SOH. So without considering the application of battery age and history of usage. Therefore, it is required to define SOH based on specific application, demanding different energy and power requirements at different times, and also based on the charging discharging pattern. So here this is a general block diagram for the estimation of remaining useful life and end of life. So initially we have to estimate the capacity and internal resistance have to be identified. So we'll be getting initial values. Then based on the initial values, right? So we have to predict the value of this RO and C in the model when it is subjected to usage and variation in temperature, and based on the predicted values, the remaining useful life and end of life has to be predicted using specific statistical tools such as Monte Carlo simulation and Bayesian analysis. So coming to the limitations of the static modeling approaches, they do not consider the battery dynamic characteristics pertaining to operating conditions specific application. So commonly electrical models are Thevenin based model and impedance based model. So this is the model. So here are two C2 combinations. So here this represents long-term relaxation effect produced due by the double layer capacitance formed at anode and cathode. So R1 C1 represents short-term relaxation effect. R0 represents the opposition to the movement of ions in the electrolyte. Combination of SOC and Q represents OCV SOC relationship. So here the Thevenin model is also subjected to change when there is change in temperature, discharging, charging current pattern, aging effect, SOC. Therefore, we need an adaptive model for identifying the parameters and also for updating the parameters online. So coming to cell equation techniques, we have passive and active cell equation
So
technique.
please conclude your presentation.
Okay, sir. So conclusions, so we need this BMS and battery technology to provide high energy and power density at reduced cost. So if effectively control the parameters of the battery and ensure safety and reliability of the battery. So the future scope for research based on the literature surveys. So we have the research work has to be carried out to build a accurate battery model based on predicting the internal resistance increase and degradation of battery capacity, and develop an SOC accurate measurement algorithm by online identifying the parameters and updating model parameters. Next one is redefine SOC based on the specific application using uses stochastic behavior and operating environment to accurately predict EOL and RUL of the battery. So we also have to develop simple, inexpensive, minimal control complexity and fast tracking methods.
Okay, sir. Okay, sir. I got your point.
Okay,
so
friends.
just can you tell me, you use some Monte Carlo and Bayesian theorem for
Okay,
estimation purpose? Yeah.
Sir, actually,
What
sir,
is
this
that?
is based on this.
Yes.
Okay, based on the literature survey, it is reported that this user data also have to be taken into account, sir, for the estimation of end of life and remaining useful life, sir. So for that purpose, we need some statistical data. So in order to predict this, so this is one of the tools, or statistical analysis tools, that is more Monte Carlo.
Yes, sir. Okay. I got your point.
Okay.
And another is you are proposing one algorithm. By that algorithm approach, we can find out the different power parameters, right?
Okay. Yes, sir. Yes, sir.
Yes. Okay. So it is your contribution?
Sir, this is only a literature survey review paper, sir.
Okay, so this is a survey kind of things. Okay.
Yes, sir. Yes, sir.
Because you are presenting block of diagram, something like that. So I am thinking that you also include your own some steps, which is different than the existing.
No, sir. This is based on the literature survey, sir.
Okay.
So I found
Okay.
out, right, these are the problems.
Okay. Okay.
Okay.
It's okay then. Okay,
Okay,
sir.
sir.
Thank you.
Thank you. Thank you. Thank you.
Okay, so moving for our next presentation. Our next presenter is Pratyusha Ravi, and she is presenting on enhanced gradual and justification methodology with local outlier factor for hardware Trojan detection.
Good afternoon, everyone. Please let me know if I'm audible and my screen is visible.
Yes.
Yeah, so good afternoon, everyone. So the title of my paper is Enhanced Gradual and Justification Methodology with Local Outlier Factor Detection for Hardware Trojan. So this paper is like coming to the abstract. With the era of this globalization, security and trust of any electronic system has become one of the major concerns. So due to the redistribution of the ICs, there are higher probability or higher chances that any malicious modifications can be intruded into the circuit, which has the capability to weaken the system by leaking some of the important information, and also has the capability to alter the functionality. These malicious modifications are commonly abbreviated as hardware trojans. So it would be better if we can detect these hardware trojans at the earliest. So there are many methodologies that can actually detect these trojans. So some of the methodologies include the reference circuits, where using which they can detect the presence of trojans or not. However, a methodology that is reference free, proficient, and experience high false positives is greatly encouraged. This particular study involves a reference-free hardware detection analysis, gradual and justification methodology, and a local outlier factor detection. Now, coming to the contribution, the proposed methodology underlines the following features: a methodology that combines signal justification, gradual and justification technique, and an outlier detection technique. Introducing a local outlier factor, an outlier detection methodology that can be applied to a list of suspicious signals produced by the gradual and justification technique. Inertia and LOF score are the two main constraints using which we can determine the presence of Trojans in our particular circuit. This particular methodology has been evaluated on the trusted ISCUS 85 combinational circuits. It also demonstrates a relationship with respect to gradual and justification methodology and local outlier factor. This is the implementation of the proposed methodology. So it is segmented into three different parts. The first one is the controllability and observability for Trojan detection. So here, first we'll be getting a gate level net list, using which we'll be determining the controllability and observability of each particular signal, and would be further classifying them. So the clustering technique here used is k-means, which is an unsupervised ML technique. The next thing is the gradual and justification methodology. So the list of signals that are reported by the COTD analysis is given as the input for the gradual and justification methodology, which would further produce a suspicious signals list. So here the performance metrics is the inertia. So inertia is generally used to determine if the data point has similar properties or varying properties with respect to its neighbors. The last part of this particular methodology is local density computation, which is the local outlier factor. So here, based on the anomaly score, we would be further determining if our particular signal or the net is either outlier or inlier. This is the block diagram of our proposed methodology. So first we would be requiring a bench file, so which is similar to a gate level net list of the ISCUS 85 circuits. So further we would be applying it to the COTD analysis, and we would be using the unsupervised clustering based on the scope measures, that is the controllability and observability, and would be defining into three different clusters based on the controllability and observability values. A cluster that has mediocre controllability and observability are not of our interest, because either high observability or high controllability would determine that these particular signals might have a Trojan. So we would be further considering these two clusters and processing them using the gradual and justification methodology. So here these two clusters are taken as reported suspicious signals and would be given to the gradual and justification methodology. The output of this particular methodology would be a list of suspicious signals, which would be further processed by the local outlier factor based on the anomaly score. So after this particular local outlier factor, the most suspicious signals list would be determined, which are nothing but are Trojans if there are present in these particular circuits. So this is the clustering analysis of the ISCUS 85 circuits. So these are some of the circuits that I have analyzed, and this is the output that we would be getting after our first block, that is the COTD analysis. So based on the controllability and observability values, here we can see that the whole circuits is divided into 3 different clusters, and they are labeled as 0, 1, and 2. So only the cluster with label 0 and 2 would be further considered and would be processed. So this is the analysis for C1908 circuit. So here the performance metrics that I have taken is the computational time. So the table shows that shows two different comparisons. Here the most suspicious signals are nothing but the signals that are produced by the gradual and justification methodology. So when you see that this particular table, this particular row, you would be seeing that the number of iterations that would be required to produce the most suspicious signals list would be higher when compared to the methodology that involves local outlier factor. Similarly, this is the analysis that I have made for C5315 circuit. So here also the performance metrics that I have considered is the computational time. So the computational time here I would be defining with respect to the number of iterations this particular methodology would be taking to define my most suspicious signals list. So here also, if we can see, the most suspicious signals that are produced only by gradual and justification methodology without the involvement of local outlier factor would be nearly 5. Whereas when you see the involvement of local outlier factor, which uses an additional feature called this anomaly score, it would be only 3. Similarly, this is an analysis that is made for C6288 circuit. Here also based on the number of iterations, I have defined my particular methodology. Coming to the conclusion, this particular methodology has been validated with all the ISCUS 85 circuits, and the most suspicious signals are reported using the proposed enhanced gradual and justification methodology, which is an iterative methodology, where the growth of this particular, since this is an iterative process, the growth is controlled by the parameters G and R. And then finally, I would be concluding by saying that there is a decrease in the computational time. That is, this is an time effective solution when compared to the gradual and justification methodology. These are some of the references that I have used. Thank you.
Hello.
Hello.
Hi, ma'am. Actually, I have one question.
Yes.
So, in your research, you are proposing some techniques to identify the outliers and also trying to find out the virus in hardware,
Yes,
as a Trojan.
Yes, sir.
Right. So,
Yes.
what is your exactly contribution? You are proposing your own, or you are just modifying existing algorithm?
Okay, sir. So now the block that you are seeing till the gradual and justification method, it is already proposed. So I have added my contribution with this local outlier factor. Like I have observed that when I use this additional anomaly score to even further process my signals list, then it is becoming a time effective solution. So this particular last block, the local outlier factor, we have added as our contribution.
Okay, so okay, you are modifying existing. So okay, modifying algorithms. So yes, so can you tell me what is the role of exactly outlier in detecting the Trojan, some malicious activity in
Okay.
hardware?
So outlier has like it has a varied properties when it is compared to the other inliers. So like they like if you consider this area, power, and all of these features as our circuit features, then you would be observing that these outliers would be posing a varied properties. So based on that, and based when they have a varied properties, they would be showcasing them with respect to controllability and observability values. Any Trojan or any outlier would generally have either high observability or high controllability. So based on that, we can further process.
Okay, good. Thank you, ma'am.
Thank you, sir.
Okay, so our next presenter is Firoz Kamlov, and he's presenting on conditional variational autoencoder based sampling.
Good afternoon. Can you please let me know if the sound is okay and if you can see my screen?
Yes, it is visible and we are audible.
Okay, wonderful. So first of all, good afternoon, and thank you very much for having me today at this very nice conference, and thank you to the organizers. Today, I'd like to talk about conditional variational autoencoder based sampling method. This work was done in collaboration with two of my colleagues, Dr. Adamu and Dr. Sharif. So what we wanted, the main idea today is to propose a new method for dealing with imbalanced data. What is imbalanced data? Basically, it's data where the target variable has a skewed distribution. And when you have imbalanced data, it causes issues like classification bias for machine learning models. So to deal with this problem of imbalanced data, today I'm going to talk about a new approach that we are proposing. Before I go into the details of our approach, let's just quickly go over the existing approaches for dealing with imbalanced data. You can basically divide the existing approaches into two categories. The first one is data-based correction approaches. So this means that you work with the data to improve the data. And then the second approach is algorithm-based approach, which means that you are designing machine learning algorithms that can directly handle the imbalanced data. Our approach falls into the first category, data-based correction. In this category, there are two main subcategories: oversampling. So that means that so if, in the case of a binary data set, let's say you have minority and majority class labels. So in oversampling, what you're doing is you're increasing the number of minority samples to the effect so that they're equal to the number of majority samples. So that's called oversampling. In undersampling, you're reducing the number of majority samples to be the same as the minority samples. And out of these two categories, the first one, the oversampling method, is by far the most popular approach to dealing with imbalanced data set. And out of all the methods that exist in the literature, the top approach, oversampling, the minority class, is overall is the most popular. And that's the approach. Our approach also falls under the same category, oversampling. Now, the motivation for our work is that the majority of the existing sampling methods employ parametric models to generate new samples. For example, something called SMOTE, which is very popular, is a parametric model. Now, the problem with that is that when you generate new samples, they are distributed according to the model assumptions. But in reality, the true underlying distribution of the minority samples is rarely the same as the model distribution. So that will skew your classification results. So to deal with this issue of the model bias, we're suggesting a data-driven approach to sampling. And in particular, we propose a sampling method based on conditional variational autoencoder, which allows us to learn the patterns within the data and generate new samples from the learned model. So we don't really assume anything about the distribution of the data. We use machine learning to understand the distribution of the data. And then we use that understanding to generate new sample points. Here's an illustration of the basic VAE structure, variational autoencoder structure. It consists of two parts. The first part is called the encoder network, and the second part is called the decoder network. So that for the encoder network, we take the input data and we map it into a smaller so-called bottleneck subspace. And then in the decoder, we take this small subspace representation and then we decode it. So we expand it back to the size, back to the space of the original input data. And when we pass the input data through this middle bottleneck layer, it allows us to extract the most crucial information about the data. And it also, because of some properties of the space, this middle space, it allows us to generate new samples. The difference between the variational autoencoder, the figure I showed before, and the variational autoencoder, like conditional variational autoencoder, is that in VAE, the loss function is conditioned on the class labels. So now let's get back to our algorithm. It consists of two basic steps. First, we train the VAE model using the imbalanced data, and then we use the decoder portion of the network to generate new samples. And this is the basic model of how it works. So here's your imbalanced data. You see there are lots of red points, but only a few blue points. We actually, this is our testing phase right now. What we do is we split the original data into two parts. You see the training set is imbalanced. What we do is we apply VAE on this imbalanced set to make it balanced. So the purple points are the new ones that we generated using the VAE. So now you have 5 red points and 5 blue points, if you count the purple ones as blue. And then we feed this balanced data to the MLP, and then we test the performance. And to test the performance of the proposed method, we used 4 imbalanced data sets. You see that the imbalance ratio starts with from 1 to 3 until 1 to 72. And 2 of the data sets are binary. The first one and the third one are binary, and the second and the fourth data set are multi-label. Also, as a benchmark for the proposed method, we compare it to no sampling approach. So just using imbalanced data and random oversampling and random undersampling approaches. And here are the results of the experiments. You can see that our proposed approach, the VAE sampling, achieves the highest accuracy for the 2 data sets in the case of binary classification. Okay, so in both cases, we have the highest accuracy. In the multi-class classification, for the other 2 data sets, we again achieve the highest accuracy. And you can see, for example, for the last data set, the E. coli data set, our method achieves 73% accuracy rate, which is significantly higher than the benchmarks. So that's really good news for us. So that's it. Thank you for listening.
Okay, hello. Am I audible?
Yeah, yes, sir.
Okay, actually, I have one question regarding to find out the bias, because you are proposing something which is also similar as we are increasing the data set when I have unbalanced data. So in previously we are trying to do so different methods like as argumentation we are using, but you are saying you are doing the training and by using the training, you are again generating the new samples. So can you tell me the exact difference or proper justification, because both are almost similar. So what is the exact change when you are saying by using your proposed methodology, it is better?
So thank you for the question. I'm not exactly, to be honest, I didn't really understand the question very clearly. Are you talking about the experiment when we balancing the training set?
Yes, we are trying to balance the data set. So existing methods are there, and you are also proposing the new method. So what is exactly difference? Why your approach is better than existing?
Right. So yes, that's a good question. Most of the existing approaches, when they generate new points in order to balance the data, they make assumptions. Uh, they make assumptions about the data set. For example, they make an assumption the data set has a Gaussian distribution, or for example, they make an assumption that it has a uniform distribution in certain neighborhoods. So most of the methods, they have these prior assumptions about the distribution of the data. Our approach is different because we make no assumptions about the distribution of the data a priori. What we're doing is we taking the data as it is, we're making no assumptions, and we're giving this data to the VAE neural network. And the VAE neural network learns the distribution of the data on its own. So we're not making any assumptions about the distribution. We're just letting the neural network learn the distribution on its own. Once the neural network learns the distribution, because it's a generative network, then we can use it to generate new samples. So the main difference is that most of the existing approaches make assumptions about the underlying distribution of the points. We do not make any assumptions. So, if you're correct about the assumptions, then of course it will work out for you. But most of the time, people have no idea what is the distribution of the data. So most likely, whatever the assumptions people are making is going to be wrong. And since we're not making any assumptions, we're less likely to be wrong.
Okay. Thank you, sir. Good answer.
Thank you.
Okay, so our next presenter is Soumya S, and she is presenting on sentiment analysis of Malayalam weights, a comparative study of auto ML and conventional ML approaches.
Let me know whether my screen is visible.
Yes, it is.
Okay, thank you. Good afternoon to all. The topic of my presentation is Sentiment Analysis of Malayalam Tweets, a comparative study of auto ML and conventional ML approaches. These are the overview of my presentation: introduction, related works, proposed architecture, experimental results, conclusion, and references. Sentiment analysis is the computational study that analyzes people's opinions, attitudes, sentiments, and evaluation from written languages. The study of sentiment analysis was initiated around 2 decades. It is now one of the emerging field in natural language processing. Due to the emerging growth of social media content in Facebook, Twitter, blogs, etc., people's opinion is very crucial for decision making. Since most people prefer to express their opinion using their native languages, sentiment analysis of regional language has become essential nowadays. Kerala, a southern state of India with Malayalam as its native language, has marked an incredible increase in the number of tweets over time. Sentiment analysis plays a vital role in government sector, film industry, political field, business analytics, and so on. Sentiment analysis of Malayalam tweets using auto ML and conventional methods is investigated in this work. Tweets are short messages with 20 characters long, so sentence level analysis is most suitable for sentiment analysis of tweets. Different approaches like lexicon, machine learning, deep learning, and transformer models have been applied for sentiment analysis and of Malayalam language in our previous studies. And in this work, the dates are classified as positive, negative, and neutral using AutoML approaches. The AutoML, which selects the right model and optimize the hyperparameters without human intervention. In early days, it was used for commercial applications, and the different AutoML packages in Python languages are AutoScalar, Tport, H2, etc. In this study, we have used AutoScalar and FLAML, that is fast and lightweight AutoML package for AutoML model creation, and AutoKeras used for AutoDL deep learning model creation. The study of sentiment analysis initiated in 2000. The first work was reported by the Pang and Lee in 2002. The study of Indian languages started in 2010, and the first work in Malayalam reported in 2012 using semantic orientation method. Some of the AutoML related works done in one of the works done in 2020. In this work, 13 different data sets have been analyzed using AutoML and without AutoML, and they have used AutoScalar, Tport, and H2O for AutoML model creation. And 9 out of 13 cases, the AutoML tool failed to beat the human performance in their studies. And another work done in 2020. In this work, they have different data sets have been compared in this work, and shows that 7 out of 12 data sets, the AutoML performed better. And another one, which is done in 2021, they have used 4 different data sets have been analyzed using different AutoML packages, Tport, HyperOptoScalar, and AutoKeras, etc. And they have used different traditional machine learning approaches, random forest, decision tree, LGPM classifier, logistic regression model, etc. And the analysis of the study shows that the ML approaches without AutoML score the highest accuracy. The research lacks in sentiment analysis of Malayalam using AutoML approaches. That is the reason I have compared the AutoML and conventional approaches. And this works have been done on 2 different data sets. And one is one data set which includes 6301 tweets, which includes both positive and negative tweets. And another one, 32,228 tweets. Here the positive, negative, and it includes positive, negative, and neutral tweets. This is the architecture of the study. The dataset has the titter includes different hyperlinks, special characters, etc. And this have been removed in pre-processing step. After the pre-processing step, it is the feature vector is created by using the TF-IDF. The TF-IDF feature vector is given to the ML model. Here, the traditional ML algorithm, random forest, decision tree, logistic regression, light gradient boosting machine, and XGBoost, these have been used for ML model creation. And for AutoML, AutoScalar, and FLAML, these 2 different packages are used for the prediction of sentiment. Then another one, we have also applied the deep learning models and the LSTM and AutoKeras, which is used for AutoDL creation, and which predicts the sentiment, positive, negative, and neutral. This is the evaluation measures of AutoML. In AutoML, by using AutoScalar packages, it returns a random forest classifier for dataset 1. The random forest shows the better accuracy. And for dataset 2, decision tree classifier shows the better accuracy. For FLAML packages, both for dataset 1 and dataset 2, the LGPM classifier shows the better accuracy. The evaluation is done based on the precision recall and F1 score. Then this the different evaluation measures for by using the conventional machine learning approaches, random forest, decision tree, logistic regression, XGBoost, and LGPM classifier. The analysis shows that for first data set, that is data set 1, the logistic regression without using the AutoML shows the better accuracy, and for dataset 2, the LGPM classifier, that is AutoML package, FLAML package, returns the better accuracy. Then these are the hyperparameters returned by the different classifiers by using the AutoML approaches. random forest, decision tree, etc. This is the evaluation measures of auto KERAS and KERAS models. And on auto KERAS, the evaluation measures are shown here. And the KERAS model, we have only applied LSTM model. And the evaluation measures shows that for dataset 1, it is first dataset, the KERAS LSTM shows the better accuracy. And for the second dataset, auto KERAS returns the better accuracy. This is the model architecture returned by auto KERAS model for dataset 1. Here, the convolutional model, and it returns the convolutional model followed by the dense layer. This is the architecture returned by the auto KERAS for dataset 1, and this is the same architecture which is returned by the auto KERAS dataset 2. So the different model parameters returned by the auto KERAS on dataset 1 and dataset 2. By comparing the accuracy of ML and auto ML, the machine learning for first dataset, the logistic regression without using auto ML shows the better accuracy, and for dataset 2, the auto ML, that is LGPM classifier, shows the better accuracy. And in KERAS and auto KERAS, the first dataset, the LSTM shows the better accuracy, and for dataset 2, auto KERAS returns the better accuracy. Coming to the conclusion, the sentiment classification of Malayalam tweets using auto ML and auto DL approaches have been applied on 2 different datasets. And the dataset 1 classifies the sentences positive or negative, and the dataset 2 positive, negative, and neutral. The study analyzed that the conventional approach shows better performance on dataset 1 and the automatic approach for dataset 2. The different models used in sklearn packages, namely random forest, decision tree, logistic regression, boost, LGPM, and LSTM are applied for sentiment analysis of Malayalam tweets. Here, AutoML has been implemented using AutoScaler and FLAML packages. AutoKERAS is used for AutoDL. The investigation shows that AutoML is not optimal for all type of dataset. Then the future work, we are planning to use AutoML packages like Dpot, H2O, Google AutoML, etc. on different datasets. Okay, these are the references. Thank you.
Okay, ma'am. Actually, I have one question because this is a very old topic. We can say the sentiment analysis. There are many researchers already did some work.
Okay.
So can you tell me the just contribution or something novelty in your approach?
Okay, I have done the sentiment analysis on Malayalam language. The Malayalam language, the data set is not available. We have created all the data set, and the sentiment tagged data set is not available for Malayalam language. And so we have created different data sets for the evaluation, and AutoML approach is not applied on Malayalam languages set.
Okay, so you are saying you are collecting the data itself is your contribution, yes? Is it correct?
Okay, data set. In Malayalam languages, very few works have been done. There is no lexical resources, and tagged data sets are not available in Malayalam. These approaches have been applied on manually created data sets.
Okay, ma'am. Thank you. Good. Thank you, ma'am.
Tejaswini Kate, and she's presenting on detection of hepatitis B virus using NFC-enabled smartphone-based portable and pedometric immunosensor.
Good evening, everyone. I hope my voice is audible and my screen is visible.
Yes.
Please let me know if any disturbance happens. I'm presenting a paper on detection of hepatitis B virus using NFC-enabled smartphone-based portable amperometric immunosensors. These all things will be, I'll be introducing my paper and objectives, main agenda of my paper, and what are the approaches I've gone through and what can be enhanced in future. This is how exactly the whole framework looks. This NFC potential stat I'm using, and this one is NFC enabled smartphone I'll be placing on it, and the blood sample containing hepatitis B virus will be placed here and will be evaluating. Despite of having advanced technologies, hepatitis B virus has always been a crucial health issue. Due to a late detection of hepatitis B virus, there were so many people who have died. According to research, there are over 37.3 million people have injured, and around 6,46,000 people have died due to hepatitis B. Currently, all the techniques we have for detection of hepatitis B are made up of huge devices, and so developing small devices to detect hepatitis B virus have been clearly a more important for convenience and for the growth also. Hepatitis B virus biosensors are used to detect the presence of hepatitis B virus biomarkers, where these sensors uses the biological marker from the biological fluid of the body. We can say that we are using immunosensors here. The electrochemical immunosensors combines the biological recognition mechanism with the transducer, which generates a measurable signals in response to a changes in the concentration of a given biomolecule. There are different type of electrochemical immunosensors, and but here we are using amperometric immunosensor, and among all the electrochemical detection methods, here we are using amperometry electrochemical chemical method. With the help of this wireless technology named near field communication, makes it very easier for the detection of hepatitis B, as it requires no physical connection, and the NFC smartphone will be placed on the NFC potential stat. So with the help of this wireless signal transfer, smartphone can easily read the data from the NFC tag. Main objective of this paper is to provide a simple sensitive tool that helps to detect the hepatitis B virus with a smartphone by making use of the low cost sensors, and to eliminate the treatment delays and preventing the wastage of medical resource. With this tool, we can detect whether there is a possibility of hepatitis B is there or not immediately. So if it's possibility, doctor can suggest the patient to go for further analysis. If there is a no possibility of hepatitis B, doctor can go for other analysis. So there will not be further medical resource wastages. In this framework, there are main three parts comes: detection circuit, and the screen printed electrodes, and the smartphone containing app. There are different electrodes have been used to operate the electrochemical methods, such as like carbon, platinum, gold, and the glassy carbon 3D electrodes. These are all as the working electrodes and the counter electrodes, and as well as AG and AGCl is the reference electrode. The glassy carbon electrode has been integrated with the gold nanoparticle polyferryle nanosheet to build a electrochemical immunosensors. Later, this SPG electrode was modified with the AUNPS and linking to beta cyclodextrin to determine the ABS antigens. Here, as this scheme 1 shows, here mainly electrochemical measurement, it occurs in two different steps. One is electrodeposition and the another one is electropolymerization. To perform this electrodeposition, the gold nanoparticles have been deposited on the electrode surface, where 0.5 m H2SO4 has been used in HAUCl4 water form, and it has been kept under 0.5 volt for 150 seconds. And this modified SPGE with the gold particle was washed in water with a from mildew, and later it has been dried at room temperature, and as well as for the electropolymerization to generate the polybeta dextrine on the surface of gold modified electron in the range of 0 to 1.3 voltage by cyclic voltammetry, 0.04 m of beta cyclodextrin in the 1 m of HClO4 was electrochemically polymerized. And now this electrode surface is a poly beta cyclodextrin gold modified STGE, so which was rinsed with the mildew water, and then the HPV monoclonal antibody was prepared by serial diluting it in 1.1 mpbs, and meanwhile to immobilize this HPV AB onto the polybeta cyclodextrin gold modified SPGA surface, 3 microel of antibody was deposited on the surface and incubated at the room temperature for 1 hour. And this resulting HPV monoclonal antibody surface will be rinsed with the ABS to remove the excess, whatever the non-specifically absorbed monoclonal antibodies are there. And then bovine serum albumin was added to this surface so that it can block the surfaces. And to obtain this bovine serum HPV monoclonal antibody surface, and this one will be washed twice and kept under room temperature for 30 minutes, and then it is washed with the twice at the PBS. So before the use of immunosensor, now it is ready for adding this hepatitis B, and before using it, it is stored at the 4 degrees Celsius. This antibody is immobilized on the transducer, and while binding to the antigen and provide a linear relationship between the concentration of the antigen, resulting into the electric signals. And then this so here later this one is NFC potentiostat. We can see there is these are the electrodes. It has NFC chip and it has antenna. So whatever the serum we have, whatever the sample we have created now will be placed here, and with the help of this one has the ADC, and this will convert this measured signal into the electrical signals, and smartphone NFC enabled smartphone will be placed onto it, and all the measured signals will be converted into digital signals with the help of ADC, and smartphone will be containing app that will be able to extract the data, and with the help of that will be able to see the data based on whatever the electrochemical method we are using. And here to express this performance analytically, we can say like this figure 2.a, it shows the amperometric curve displayed on the smartphone screen. And here we can see this line is with the HPS antigen, and this one is without HPS.
Sorry to interrupt you, but you have last 1 minute.
Oh, okay, yeah. This one is with the HPS, and this one without the HPS. So it shows that it decreases as the concentration of HPS added, it decreases the current response. Here, these are all the different concentrations amounts, and we can see this one has 200 microG. So it shows that current response is decreased. As this one is specifically for the HPS, so we can go for different blood samples also, and there is still so more development like rapid sensitivity disposal we can go for, and even for biodegradable devices also. This whole framework was successfully developed, and it will be helpful for the detection of the HPVS and minimal usage of the medical resources. And these are the references I found. Thank you.
Okay, how you compare your result with existing? Is there any existing system?
There
the
are
same
similar,
purpose?
yes, okay. There are similar researches have been done, but their agenda is either they are concentrating on the electrochemical methods sensing they are using, or either they are concentrating on the how this NFC tag is developed from the silicon craft. And my agenda is to detect the hepatitis B using the amperometric measurement.
Okay. And as per the cost, related to the cost, how you compare whether your system is cost effective?
Yeah, it is a one-time investment, sir. Like for the NFC-enabled smartphone, if we want to purchase around 40,000, it will cost. And for this NFC tag, I would say $0.75 it would cost. So it will be a one-time investment.
Okay. Okay. Thank you.
Thank you.
Our next presenter is Parimal Tiwari, and he is presenting on dual band monopole antenna with dual stub and microstrip fading for land, WiMAX, and satellite communications applications.
Am I audible, sir? Good evening.
Yes, you are audible.
Thank you. Good evening, everyone. The session chair. Myself, Parimal Tiwari, I am the research scholar in the Department of Physics and Electronics and Dr. Ram Manohar Lohia, Awadh University, Ayodhya. So what I'm going to present is my research paper on dual band monopole antenna with the dual stub and with the fed with the microstrip feed line for WLAN, WiMAX satellite communication applications. So this is the outline of my presentation here, the introduction, research objectives, literature survey, some parts of the literature survey is going to present here, the proposed work, and the parametric analysis and the results and the discussions. After that, the conclusion and the reference last. So as we all know that in today's era, as the wireless communication is gaining the new heights day by day, so the miniaturization of the antenna is also required. So to fulfill this need, the microstrip antennas are very much attractive because it is having lightweight, it is low profile, and of course it is of low cost. There are several shapes of the microstrip patch antenna. What we can design is in the square shaped or the rectangular or the circular shape. Hexagonal, there are many more shapes of my desires. So what it actually consists of, it has the patch which is mounted on the dielectric substrate and at the top, and in the bottom it is grounded, and it is suitable for various applications like narrowband applications and the wideband frequency applications. There's the schematic diagram of the microstrip patch. The blue one is the patch which is mounted on the dielectric substrate and below the ground plane. So what are the advantages is that it is low cost, very easy to design, easy to fabricate. When in the materialistic world, we are easily getting the materials, and the fabrication is also possible. It is of lightweight, and it is capable of generating dual, triple, multi-band frequency operations. The disadvantage is that it provides very low bandwidth, narrow bandwidth. The gain is also low. Efficiency is low, the low power handling capability, and it is also affected by the spurious field radiation. Means that if we are designing the if I'm designing my microstrip antenna for particular application, so some more radiation is also possible, which is unwanted. So these are the some of the applications that we can use for wireless local area network, for WiMAX, for GPS bandwidth, GPS and Bluetooth. For narrowband, wideband, ultraband frequency, we can use it. There are two types of feeding techniques are there. The first one is microstrip feed, in which a conducting strip is connected directly to the edge of the microstrip antenna. And the second one is the coaxial feeding, in which the coaxial feed is is feeded with from the ground, and its top edge is touched to the patch which is mounted on the substrate. What my research objective is to design the multi-band antenna for multi-band applications, which is to improve the impedance bandwidth and to design the multi-band monopole antenna with having the large bandwidth coverage. These are some of the literature survey what I've done. I've gone through many more papers, but I'm pointing out here some of the papers also. The first one is the design of the microstrip fed dual band design, which is fed with a 50 ohm microstrip line and is generating a dual band at the 2.4 gigahertz and 5 gigahertz with a bandwidth of around 16.3 percentage impedance bandwidth and 16.9 at the 5 gigahertz frequency band. And the second one it is also generating the dual band at 2.4 and 5 gigahertz, which is using the FR4 material, which is having the relative permittivity of 4.4 and thickness of 1 mm. Third one is it is also generating the dual band, which is having the 12% and 35% of impedance value what we are getting at 2.28 to 2.56 gigahertz frequency band and 4.64 to 6.64 gigahertz frequency band. And the last what design of the simple microstrip antenna is presented with the protruding stub in the ground plane. The stub is protruded in the ground plane, which is also generating the impedance bandwidth of 5.81. Impedance bandwidth of 31.14 and the 8.75%. So this is my proposed work, in which you can see that the modified feeds are used with the two stubs. The first stub is the LST1 denoted by, and the second stub is denoted by the LST2. The right side is the bottom view of the microstrip antenna, which is having the ground. This LG is the length of the ground. The table shows the what are the different dimensions what I have taken for designing this microstrip antenna. And this antenna is designed on the substrate of FR4 epoxy, which is having the relative permittivity of 4.4 and the dielectric loss tangent of 0.02. This antenna is having the thickness of 1.6 mm and the dimension is 39 mm across 28 mm. Okay, some of this is the evolvement. This is the different arrangements of the antenna from what I have started. The first one you can see the antenna was denoted only the what I have taken this the modified feed with the rectangular patch you can see. So after getting this on the HFS, I've used the software high frequency structure simulator HFSS version 19. And on that simulator, I have first designed this antenna one. What we can see that this antenna one is generating only single band below the minus 10 dB S1 parameter. So the bandwidth you can see that 30%. After that, the antenna 2 was designed, in which I have put a single stub. Because of that single stub, I am getting two bands. What you can see the dashed blue line at around 2.6 gigahertz and around 7.2 gigahertz at this point. But it is having the less return loss and low bandwidth. And finally, what I propose that when one more stub is placed onto the patch at the right side, you can see that because of this, we can see that two bands at the required 2.7 gigahertz and 5.7 gigahertz with improved impedance bandwidth of 30% and 67% at both the frequencies generated. So this antenna covers proposed antenna covers the frequency ranges from 2.4 to 3.2 gigahertz with the resonant frequency at 2.7 gigahertz, which is applicable for WiMAX and lower band of WLAN frequencies. And at the second band is ranges from 5.3 to 9.1 gigahertz at the resonant frequency of 5.7 gigahertz, which is applicable for the upper bands of WLAN and the satellite communication applications. So some of the parametric analysis I have done using by varying the different attributes of the antenna, like you can see the LST1, the feed 1, the feed 2, and the patch width of the patch. So the first S11 parameter is that we can see that when I'm varying the length of the ground from 11 mm to 13 mm, so we can see the variations from here, that we can see the variation from here that at LG is equal to 11, we can see.
Sorry to interrupt you, but you have last 1 minute.
Okay. So these are the parametric analysis what we can see by varying the length of the ground. We can see that what I have proposed when LG is taken 12 mm, we are getting the desired output with the improved bandwidth. Here also, when I've varied the width of the feed 1 from 2.5 to 3.5, then also you can see the S1 parameter. Here the length of the stub 1 is varied from 5 to 7 mm. This is the parametric analysis. And after that, the length of the patch is also varied from 20 to 22 mm, in which we are getting the, when LP was taken 21 mm, we are getting the optimum result. So this is the gain what we have got, that from at 2.7 gigahertz, I am getting the gain of 2 dBi, and at 5.7 gigahertz, I am getting the gain of around 4 dBi. So this is the radiation pattern. We are getting the radiation pattern is similar to the omnidirectional antenna as the figure of 8. This is the surface current distribution of the proposed antenna at 2.7 and 5.7 gigahertz, in which we can see that the surface is leaking through the feed of this antenna. Okay, and in both the cases at 2.7 and 5.7 gigahertz. This is the comparison between the reference antennas and my proposed antenna. The size of the antenna of my proposed antenna is very less as compared to the what references has been gone through. So this is a conclusion that it is miniaturized shape. The size of my antenna is 39 cross 28 cross 1.6 mm cube, and the frequency is covered from 2.4 to 3.2 gigahertz, which is applicable for WiMAX and WLAN, lower band of WLAN, and from 5.3 to 9.1 gigahertz, which at the resonant frequency 5.7 gigahertz for upper band of WLAN, and for satellite communication applications. The bandwidth, the improved bandwidth, we are getting at 30% and 67%, which are achieved. And the gain is also we are getting that 2 dBi and 4 dBi at 2.7 and 5.7 gigahertz. And my antenna is behaving just like the omnidirectional radiation pattern. These are some of the references. Thank you.
Okay, thank you, sir. You have given very good presentation. I have one question. Actually, if I am not wrong, many researchers are doing some research related to the antenna, and you
Yes,
are
sir.
saying your antenna is cost effective. So can you give me the more justification on how your antenna is better than existing in with lower cost you are proposing with the antenna?
You're saying that how can I justify the cost of this antenna?
Yes.
Since I've just started my research work in this proposed field. So right now I'm just doing the simulation part of work, and because of the labs are closed, the fabrication is not possible at this very time. I've talked to many of my senior professors at IIT BHU and IIT Kanpur, because this fabrication lab and the measurement lab is present there only. So as soon as I can go there and do the fabrication part of this antenna. It is cost effective because FR4, what substrate I have taken, sir, FR4 epoxy. This is the it is very much cost effective. It is very much of low cost material. It is easily available, and the fabricator using the fabricator of some Integral technology is providing the PCB prototype for fabricating. So it is not so very much costly. So this FR4 epoxy substrate is easily available, and is of some 100 rupees, 100 to 200 or 300 rupees cost of a single sheet. It is of. So
Yes, right. I am saying the same because similar technology is there. So you said your technology, your whatever you are proposing, it is cost effective. Lower cost, you can implement this one. So I am
sir,
asking in which part you are
uh,
in which part you are saying this is a better than existing. Yeah, small part we can consider, but this is the part it is a costly in existing, and this is the part is easily available in your proposal.
so that is why that is what I'm saying, that the substrate material, what I'm using, the FR4, it is named as FR4 epoxy substrate. It is the cost effect. It is of low cost. Plus, my dimension is also getting miniaturized. My dimension is also getting miniaturized through parametric analysis of what I have done, and I'm getting the better result. So miniaturized dimensions with using that low cost FR4 substrate on which I'm mounting that patch and designing my that antenna, myostrip antenna, is collectively making it of low cost. Sir.
Okay. Okay. Thank you, sir.
Thank you, sir. Thank you very much, sir.
Okay, now I think okay, now I sincerely thank our authors for their excellent presentation and contribution in this session. Uh, all our participants for being a part of this international conference. We hope this session was informative enough. We, on behalf of whole team, thank you for the support during this version and the previous sixth version of the conference. We will be happy to have you all in the eighth version of the conference in 2023. And further, all the presenters will be getting their digital certificates through email within 2 working days. And all the papers have been already forwarded to the stranger. The publication will be live within 5 to 6 months, so kindly cooperate with the team ICT4SD 2020. I also thank our session chair for chairing the session, and there's one token of appreciation. So this is a token of appreciation on behalf of chair of team ICT4SD 2022 and the Global Knowledge Research Foundation.
Okay. Thank you. Thank you.
Thank you, sir, for your valuable presence. Okay, now I would like to request you all to turn on their camera for a quick snapshot of the conference. Thank you all.